In this lesson, we're going to talk about radians, applications of radians, specifically an arc length. An arc length is actually something that would have came up in a geometry class, so we're going to kind of give a geometry feel to this. But an arc length is really just a fraction of a circumference. So kind of here's a piece of a full-on circumference, and your angle in here is known as a central angle, and that angle is going to play a pretty significant role of kind of how big the arc is. So, if you were in a geometry class, you would have figured out that here's your circumference, and it's just a fraction of that circumference. And your fraction is based on degrees just out of 360. So there's your fraction times circumference, simplify everything, and then there's your answer. Here, if we have radians, really doesn't change. Rather than being out of 360, we're out of 2 pi. So whatever our radian measurement is, out of 2 pi divided by 2 pi times your circumference. Now the one nice thing that does happen with this is your 2 pi's will always cancel. And so really it just becomes your radian measurement times the radius. And if you don't remember that, great. It's not a big deal. If you do, that's great. But if you don't, that's okay. It's still just a fraction of circumference. So if something is starting in radians, I'll probably leave it in radians because I like the 2 pi's will cancel. So then I just set it up. So if we're looking for the arc length, we're going to have 2 pi times our radius times our fraction out of 2 pi. And then immediately I'm just going to cancel out my 2 pi's, and so really it's just going to be my radian measurement, my angle, times my radius. And we would just throw that into the calculator, and that's going to get us approximately 21.44. That's it. All right, and then we have a second one. This one's a little more wordy, a little bit more of a word problem, where you're looking at two different cities. One is Reno, which is almost due north of Los Angeles. Reno's is about the 40-degree north latitude, and LA is about 34 degrees north latitude. Find the distance between them. And we're going to need Earth's radius. The fact that Earth's radius is roughly 6,400 kilometers. So the reason that this is in this arc length is because we're actually talking about an angle measurement here. So Earth is 6,400 kilometers, and they are a distance, but they're a distance on a circle. So we're going to try to figure out what that length is. So we need to know the fact that LA is 34 degrees and Reno is 40 degrees. That puts the difference between them at 6 degrees. So that is our measurement. That is our angle. So for our arc, we need 2 pi times circumference times our fraction. And since it's degrees, we're going to do 6 out of 360 and put that in the calculator. So that is roughly 670 kilometers when you put it into the calculator. Okay, and we'll do one more video that it's a little bit longer. We're talking about 2 different cogwheels turning. You have a smaller one turning and a bigger one turning, and we'll kind of see how the arc lengths play out on that one. But we'll do that in the second video.